So if you are just joining us, we want to say welcome to OWCC 2024. I'm excited that we have reached this far, and it's all because of beautiful, hardworking, and diligent people like you that stay committed and consistent to this program. And today we are here on day 5. So kudos to yourself. Just let us know where you are joining us from in the chat box and also say your name. Let us know where you are joining us from in the chat box. Thank you so much. I hope all of the volunteers are here, especially to those of you that have a part to play here today. I hope you are all here. Okay, so let's get started. So let's get our welcome remarks from Evans Gibson. So Evans, if you are here, let me just send you an invite to unmute yourself. You should be able to see that notification. Evan, you can unmute yourself and give us our welcome remarks. Yeah, go ahead, Evans.
Okay, so good day, everyone. Evans S. Gibson, and today I'll be doing welcome remarks. Excuse me 1 second. Okay, so dear participant, we are delighted to extend a warm welcome to you as a participant in our online winter computer concept OWCC 2024 training program. On behalf of our dedicated team, we commend your enthusiasm and commitment to expanding your knowledge in the exciting field of computer science. Over the course of this program, we aim to provide you with a comprehensive understanding of various concepts and topics that form the backbone of computer science, whether you are a beginner eager to dive into the world of coding or an experienced professional seeking to enhance your skills. We designed this program to cater to learners of all levels. Our team of experienced speakers, industry experts, and passionate educators has materially curated their materials, among others, to ensure a well-rounded learning experience. By the end of this training program, you will have a solid foundation in fundamental principles of computer science and be equipped with practical skills necessary to tackle real-world challenges. So welcome once. Thank you.
Okay. So that's it, ladies and gentlemen. Welcome to day 5 of OWCC 2024. Let's take our next part here, which is the overview of TIT. I think you have listened to this a couple of times, but let's play again.
DEA Innovative Tech, DIT, with the color representation of green, blue, and white. It was founded in 2018. It is our vision to use technologies to transform lives. There are lots of great minds out there, but the opportunities to learn and grow haven't been presented to them. DIT will use technology to provide career guidance, personal development, national transformation, tech events, and much more. DIT is operating on these 4 pillars: develop, build, connect, and impact. These pillars can be applied to individuals, groups, companies, nations, and society at large. Activities of TIT since its establishment have been: 1. Personal development of the founder in terms of higher education and networking with great minds. 2. Producing educational videos about computer science or tech, networking, windowing, programming, IoTs, web development, etc. These videos are being uploaded to DIT various social media platforms like WeChat, Facebook, YouTube, etc. 3. Organizing special classes or tutorials for individuals among others. 4. Web development projects. 5. Conducting global webinars, which are done during the winter and summer seasons, and many others. The prospect of TIT is to establish a free online learning platform and technical schools throughout Africa and the world. The takeaway for the audience are: 1. Exposure to a certain domain, some might be in a state of dilemma. 2. Career or educational guidance. 3. Hands-on from the speakers, practical tips, tools. 4. Connections or networking with like-minded people within the industry. 5. Certification. 6. Future partnership. DIT is open to partnership for the betterment of humanity and society. We can only have a minimally criminal-free environment, job opportunities, small businesses, entrepreneurship, and a vastly growing economy when the minds of young people are geared toward finding solutions through the use of technology. Where there is a lack of creativity and innovation, the nation and its people are doomed to stagnation and economic hardship. So, join us at TIT as we develop, build, connect and impact.
Okay, so that's it, guys. Join us at TIT as we develop, build, connect, and impact. Someone was saying they can't see the screen, but I think someone just confirmed that they can see it. So if you are just joining us, welcome to day 5 of OWCC 2024. We are excited that we have reached this far. And unfortunately, probably some people missed yesterday, and some people also missed today. So that means 2 days out of the 6 days, you are not qualified to get a certificate. But for those of you that have been here from day 1 to day 5, rest assured that we already have you covered. So somebody said the QR code on this is not visible enough from the WhatsApp group. So I will resend it, especially the QR code aspect. Then you can take it up from there. So after the program today, I will resend this flyer and also send a QR code so that you can join. The application process is still ongoing. If you have been here for the last 3 days, we have talked about this a lot. So if you're just joining us today, if you are just watching the video today, this is the Ohio University 2024 admission, and the process is ongoing. You can use the link right beneath the Ohio University 2024 admission to process your application. The second link there, you can use it to read more about the program, about the university, and all of that. There are 3 campuses of the university in 2 cities. 2 campuses are in Nanjing City, and 1 campus is in Changzhou City. So you can see the description there, and I think it's a beautiful campus from what you are seeing. And from my own experience, because this is where I am, there's a university that I'm attending. I can recommend anybody at any point in time to attend this university. For me, it's the best so far in China. You like it or not, it's the best in China. The process is ongoing, so use my information as a recommender. And then after you submit your application, you can let me know. Let me know if you need any other thing. Just send me the application number after submitting your application. If you're using a mobile phone and the screen is not widened, you can use your 2 fingers and just zoom in on your mobile phone. But if you're using a desktop, I think it should be widened enough. Just let me know if every one of you can see the screen properly. Okay, so if you just joining us, welcome once more. Let's move on today. We have a lot of things to talk about today. Tomorrow we have Bosco to talk about his upcoming or his EP that will be released next month, according to him on the 14th. But he's going to talk more about it and also talk about his music and all of that. So tomorrow he will be here at about this time to talk about his music. Maybe if time is permitted today, we're going to play maybe 1 or 2 of his songs so that you can listen to it and catch the vibe to know if actually this person music, it's, I can really feel something in it, not to waste our time and all of that. But I can assure you that his music They are all good, and you're gonna love it. He's also a student here, I think, doing his PhD in China as well. So we have a couple of people joining this program from different places. That's why we always ask you to let us know where you are joining us from, your name and the country or region you are joining us from. You can let us know in the chat box. Okay, the person that had the screen issue said they have resolved it. Thanks to all of the volunteers that did extremely well in organizing and also in the publicity as well for this program to become a success, because we have already reached day 5 and I can already count it a success. Thanks to Alice, Francine, to Ahmed, Miata, Stanley, Nakili, Jala, Shamima, Emmanuel, Tina, Hosan, and also the next list of volunteers, Joanne, Kaju, Salome, Wise, Delphine, Magnus, Agnes, Flomo, Daniel, Topa, and we also have the last set of volunteers, Nimpan, Jalate, Joseph, Evans, the person who gave us our welcome remarks today. Somebody have started doing annotation. Let me just stop that. Some people don't like peace. They like violence. So stop annotating. I'm going to disable that feature when I get on another computer. Can someone already have a PhD partial scholarship in China who wish to change? I'll get back to your question later on. Let's move on. Let me see if I can find your question here. So the certificates, they are being processed. We can assure you that we already have completed 98% of the certificate. We have completed 98% of the certificates. We told you yesterday that we're going to start working on it. And today we can assure you that 98%, let me see if I can show you the certificate. Let me see if I can show you the certificate. We have already done the certificate for speakers. So you can see that we already have the one for participants. Let me see if I can change the view here. Well, some of you can already see your name, so we already have the certificates for you guys. They are all here. The thing is, some people, your certificate was not processed because number one, you did not register. So we don't have an ID for you, because when you register, the system generates an ID for each person. So we don't have that ID. That's why we have not created your certificate. But we're going to generate those ID, at least for those of you that did not register for the program, but you attended 5 or 6 days. We're going to generate that ID for you guys by the end of today. But all those that register for the program and attended from day 1 to this date, we already have your certificate here. We already have the certificates here for everybody. So just wasn't assure that it is here. But if if you do not complete today, and also if we cross-check the record from day 1 to day 4 and find out that you also missed some of those days, and also tomorrow if you miss, so all in all, if we check, we just prepared a certificate for all those that have been attending. But before we give you the certificate, we want to cross-check your attendance record. So if you miss 2 days of the 6 days, then we will not get or give you your certificate. I think, Yan, you did not register but you have been attending. I've seen your name. So all of you that have registered, your certificates are here. I think some volunteer, imagine, have not registered, so there is no certificate here for that person. But we already have a certificate for 98% of those of you that have attended the program from day one to today. The certificate being here does not mean you are going to get it. We also have to cross-check your attendance record to make sure that you actually attended all of the days. For volunteers, your certificates, they are also here for volunteers. Your certificates are here as well. They have already been prepared. So you start to receive them by tomorrow. And also for the speakers, we already prepared all of the speakers' certificates. So they will start to receive the certificates by the end of tomorrow. So yeah, this is how fast and how far we can go with our preparation. And we want to say thank you guys for joining. We will complete the remaining certificates by cross-checking the attendance of today. And also for some of you that did not register officially, but you attended the program from day one up to today, we also going to prepare a certificate in that fraction as well. So that's it for the certificate aspect. Your ID will also be on the certificate. You can use that ID to verify a certificate if you want to. You can use that ID to verify a certificate. So let's move on from there. Back to our PPT. So you already seen the website to verify a certificate. We have shown the website so many times. Sorry, let me just switch this guy from here. Just a minute. So if you want a certificate to be arranged in whatever way, you can let us know, and we will try to do that for you. We'll try to do that for you. But so far, so good. We have already arranged all of the certificates. So let's move on. We have had Abel on the first day. On the second day, we had Tien Ipan that talks about his experiences from building large language models. Yesterday we had Daniel, but on day 3 we had Data Mountain, and yesterday we had Daniel. Daniel will be here with us tomorrow to complete his demonstration on the Odoo framework or on the Odoo system. So some of you that have already installed it, you can keep playing around with it. I think somebody said in the WhatsApp group that Odoo deleted a file, but I try to ask the person what happened. I hope I can get update from the person and also resolve that. Today we're going to have, another speaker today. So tomorrow is the last day for the program. Tomorrow is the last day for the program. You can see the certificate has been updated. If you compare it to the last or the past days, Tien Ipan name was not here. It was, I think, Professor Chris. But we have updated the certificates and all of that. So they are already set and ready for distribution. We'll start to distribute the certificate immediately at the end of tomorrow. So once we close the platform tomorrow, you start to receive your certificate. If you want it through WhatsApp, through WeChat, through Messenger, through email, whatever way you want it. By default, we'll try to send it out to your email by default. If we can't find you via your email, we will also send it to your, if we have your WeChat or WhatsApp, we'll also send it to those mediums as well. Also, if you are not in the WhatsApp group, because we'll not be here again after tomorrow for you to check with certificate and all of that. So the way you're going to get us is through the WhatsApp group and through the WeChat group or through the website. Try to follow these platforms as well to keep up with things that are happening there. And also, we also have a WeChat channel and also a WeChat group and also the Facebook page. As of, let's say, since this program started, you know, only 4 persons have subscribed to the YouTube channel of TIT. That is Saku Bendi, Tramor, Tokpa, Sanju, Adam Case, and Amandu. These are the people that have subscribed to the YouTube channel of TIT since we started this program. Since we started, if you think you subscribe and I didn't mention your name, you can let me know in the chat box. I will verify that now. But these are the people that have subscribed to the YouTube channel since we started. Some of you subscribed to the WeChat channel. I've already have that record. Probably tomorrow I will give you the update on that. For the Facebook page and stuff, I think some people, I think Fina and some people have already been interacting with the Facebook page, but the vast majority of you haven't. Can you imagine? So I will verify that, Harrison. Maybe it's today. Yeah, so even I think it was in the past before the program started, but for the last 5 days, these are the people that have subscribed. So if you haven't, please do. We will check with that as well. It's just a way of you supporting us. We don't charge you for these programs and any other things. It's just a way of you showing your love to us as well. So just go to YouTube and search for TIT, or you can search for OWCC 2024, and you're going to see one of the videos. From one of the videos, you can also use it to find the rest of the videos and also the channel. Check on Facebook. I think many of us use Facebook every day. Go on Facebook and check for TI Innovative Tech, TIT, or TIT Unique Technology, and you're going to find us. I'm going to share the link in the group here later on when the speaker is going on. I'm going to share the link. So please try to subscribe and show us love as well. If you are in China and you cannot get access to these things, you can scan the QR code here to join the WeChat group. I will add you there. That's my QR code. And also the one below is the WeChat channel of TIT. So on the first day, we gave you some AI tools and sites to boost your productivity. I hope you already have these ones. If you don't, you can take screenshot now. They will not be shared in the group, so do not expect it. Also, on the second day, we had additional lists. So from the description, you can know if it's matching what you want to do or not, and then you can follow up with that. Also, on day 3, we had the following list. We had a following list on day 3. You can take a screenshot of it. On day 4, which was yesterday, we had this list on yesterday. So if you're just joining us, the certificates are ready. But in case you do not complete today or stay until the attendance, and also you have missed any of the other days from day 1 to today's date, that means probably you already missed 2 days. I'm sorry, we're gonna give you a certificate. You have to attend 5 of the 6 days or all of the 6 days to get or be qualified for the certificate. So that's the only requirement you have. You don't have group projects, you don't have anything. So this is the only thing that you have to do just to stay throughout the program. Today we have this list for you. We'll also send this one in the chat box later on when the speaker is going through. We will send this list in the chat box for today, not for all the other days, only for today's. So you can also take screenshot while you are with us to send it in the chat box. You can also take screenshot of the list for today. Tomorrow as well, we're going to give you the last section of this. But in the future, if you still need more, you can also reach out to us on specific kind of for AI tools and website for especially what you are doing. And we can be able to fetch those information and provide it for you. You can also use day 1, number 1, which is ChatGPT, to ask for additional lists of things that you are into, and you can take it up from there. So on tomorrow, we're going to have something. Let me check first to see if the speaker for today is here. And also, Kaju, you can start to get ready. You can start to get ready to introduce our speaker for today. But let me check to see if first thing I have to unmute. Kaju, you can just unmute yourself. Let me check for the speaker. Okay, the speaker is here as well. Let me just send him invite to unmute himself. And also, okay, so yeah, later I'm going to activate the camera, but let me just talk about something quickly. So on tomorrow, we will have, like I said yesterday, a mini dialogue for 15 minutes. We need 4 persons, let's say eight persons. And then it's going to be 2 teams, a team of 4. So 4 persons will be on one team, 4 persons will be on the other team. So let's do it now to find those people, and then you can start to prepare. You can start to prepare between today and tomorrow. You can start to prepare. So if you want to participate in the dialogue or the debate for tomorrow, it's not going to be observing all of the debate rule, but we just want to have a little discussion from you, the participant, after being here for all of these days. We want to also hear from you through dialogue. The topic is going to be on, do you think, let me just read it. It's going to be, do you think students should use ChatGPT or generative AI tools for their academic research, for the academic or research work? Do you think students should use ChatGPT or generative AI tools for their academic or research work? That's the topic. So we need 8 people. We're going to split them into 4. And then 4 persons will be on team A, another 4 people will be on team B. So if you want to participate, what we're going to do now is to get these 4 people. So just use the feature of raising hand. The first 8 persons that will raise their hand, we're going to put you in this raffle draw quickly and then take off from there. So if you want to participate, we encourage ladies as well to participate. So we already have 3 person hands raised. If you want to participate, please raise your hand. Okay, we have 3 person, 4 person. Okay, let me just try to enter your name here quickly. Number 1 is Morris. And then number 2 here. Number 2 here is Abdullah. Number 2 is Abdullah. Number 3 is Emmanuel Chia. Number 3 is Emmanuel Chia. Let me just put Eman Chia. And then number 4 is Robinson Blamo. So the winner will get 5 USD scratch card. If you are in Liberia or other part of Africa, you get 5 USD scratch card to at least top up your data for all of the time you have been here using your data. So Ara Blamo. And then we have Joseph Nangbe. We have Joseph Nangbe. So for now, you don't know which team you are on. We're going to tell you shortly. So J Nangbe, NAGBE. And then we have Case. Case, I assume that you're going to put your hands up. So if you observe first, your name was here. Case Lee. Where are the ladies? I needed some ladies to participate. If any lady put a hand out, I will replace them with 1 man. So JK Chrome. J Chrome. Yeah. And then the last person here is Elijah. Hey. Somebody else, but before Elijah, somebody hand is up. Ebu Eso. Okay, let's see. EBOU. I think you already know yourself. You're the only person here. Elijah. If somebody else can put a hand up, then we can do it 5-5 on the team. Elijah hand is up, but he don't have. We cannot make it 9. We need 10% if we have to do this. What spin is this? Don't worry, we're gonna show you shortly. Don't worry. Josephine, okay. Oh, but still put Josephine name. My hand is up. Kaju. Kaju hand. I didn't put Kaju name. Okay, so let's go with this. These people, I think. So now what we're gonna do is this. I'm gonna spin the wheel, and after spinning the wheel, you will, once your name appear, or you, like you have been chosen, then you will be automatically on team A. So please write down your team member. The first person name that will be chosen will be the team leader. So please write down all the people that will be on your team, or the other people can also write down those names. The second person that will be chosen will be on team B. The third person will be on team A, fourth person like that. So it will keep going in that faction. First person, team A, second person, team B, third person, team A, fourth person, team B. So let's go and find the first person that will be on team A and also be the leader of team A. So I think Eleni here on Emmanuel Che. So Emmanuel Che, you'll be dropped from this list. Now we have the other people left. Let's spin it now. This one, the person I'll be choosing will be the leader of team B. Oh my God, I hope I didn't do anything wrong here. So Jay Nambe, you are the leader of team B. So please write down all the people that will be on your team. Now the next person is going to be on team A. So, hey, Maurice just passed by you. So Abdullah, I think that's you. You will be on the other team. Let's spin it again. Team leaders, hope you are writing your people name down. So I think it's on Arab Blamo. Okay, so let's go again and find the remaining people. So the winners are gonna get 5 USD scratch card or Hongbao if you are in China. Winners gonna get 5 USD scratch card or Hongbao if you are in China. If you are out of China, you will send it through mobile money. You receive it through mobile money from us tomorrow. I hope Gideon is on the platform. He will be the one sending that money through mobile money to those in Africa. Thank you. The last 2 people. Let's see. Okay, I think it's 4 on the green side. Because Lee. So automatically the last person, you know where you stand. But now let's choose the topic quickly. Let's go over the topic and see. So team A, you are going to be on the first side of it here. Let me just make sure that I have the screen. I share here properly. Sorry guys, let me do this. This guy, I don't want to go up. So hope you have recorded your people's name. Okay. Ooh. All right. So you can start your research, guys. Come on, let me just find this thing on the other screen here. I'm using two different screens, so it's kind of for. So now we're going to know which team is going to be for and which team is going to be against. Which team will be for, which team will be against. We're going to see that shortly. Okay, so team A, that means you are telling us yes, that students should use ChatGPT or generative AI tools for their academic or research purpose. So you will be defending this topic, and the other team will be saying no. So let's pin it and see which team is going to be selected. So team A, you will be defending the topic, telling us yes, that students should use it, and the other team will be telling us no, students should not. You guys can find yourself in the chat box on WeChat, WhatsApp, or here on the Zoom platform. You can find yourself and better know how to group yourself. Maybe you can create your own WeChat group or your own WhatsApp group and take it up from there. So that's it. We will have that tomorrow. So please do your research today and tomorrow, and then we take it up from there. So to our speaker and also to the volunteer, please, you can take it up from here now. Kaju, you can proceed by giving us our Kaju, are you there? Kaju? Oh, you are muted? Let me check. Please check again. You should be able to unmute yourself.
Yeah. Thank you, CEO.
Okay, you can go ahead, Kaju.
Yeah, so thank you very much. I'm Kaju Kusha, and our speaker for today, he's an embedded system developer, automotive internet engineer at DCSV. He'll be speaking to us on vehicle network protocols, and he's Cedric LESSOY.
Okay, so ladies and gentlemen, please give it up for our speaker for today. Honorable speaker, if you are there, please, can you just try to speak so that I can find you? Come here also, let me see from here. So guys, please welcome our speaker. Okay, you can unmute yourself.
Yes, it's
now
okay
it's
now.
okay.
Yeah, it's okay.
All right, so let me also give you the permission as well to share your screen. Yeah, you can go ahead and share your screen. And also
I cannot do it with my phone.
yeah, okay, let me also do that.
Okay, let me raise my hand. Okay,
right.
Okay.
All right. Yeah, you can turn your video on also from the phone. I think it should be possible.
Yeah,
right?
it's okay.
But the phone you can flip the screen. It's in
it's okay.
it's
Can you see me?
horizontal. You can yeah, we can see it, but the screen is flipped in a vertical format. So you can just turn the phone around.
Oh, okay.
Okay.
I'm sorry.
Yeah.
It's okay now.
It's a bon. Yeah, it's okay.
So can you see me well? Can you hear me?
Please turn it on again. I'm sorry, I think I just did something.
Okay. Give me the permission.
Yeah, you can go ahead. Just
let me erase.
Yeah, you should be able to turn on the camera again.
Okay. No,
From the
I can't. I can't. I can do it from the mobile phone.
Okay, let me see. Okay, start now. You can do. Okay.
Okay. Mm,
All right. You can also share your screen. Let's see if we
okay.
can find you.
It's okay
Okay,
now.
good. It's okay.
Good.
It's okay. Yeah.
Okay.
All right. So, ladies and gentlemen, I present to you your speaker for today. If you can hear him and also if you can see the screen, please send a message in the chat box. If you can hear and also if you can see the screen, please let us know in the chat box. If you can see him and also if you can see the PPT or the screen, please let us know, guys. Okay, yes, they can see it. You can go ahead, my friend.
Okay. So, hello everyone. Good morning, good afternoon, or good evening from where you are. So, it's truly an honor to be here today. I want to express my gratitude to Mr. Orlando, CEO of TIT, for the invitation to speak on vehicle protocol networks at this OWCC 2024 session. So my name is Cedric LESSOY, and I come to you with a background in automotive Ethernet, but it's actually not my educational background. So yeah, as you can see here, I majored in telecommunication engineering and in information and communication engineering. So I have a master's degree in both of them, but my first master's degree, the telecommunication engineering one, I got it from my country, Ivory Coast. So I'm Ivorian. Uh, then I got here to China for the second master's degree, but this time in information and communication engineering. So as of now, I'm an embedded developer, software developer, sorry, at the CSV in China. So we are specialized in developing state-of-the-art technology for the automotive industry, specifically in autonomous driving. So we have a lot of car manufacturers as partners, such as the Chinese brands Changan, BYD, Li, and so on, if you know them. So, um, um, yeah, in my years of working um, in the automotive industry, I've had the privilege of working on several projects, such as building an enhanced testability service for some IP protocol. Um, Also another project such as designing computing platforms like those the leading automotive industry giant Tesla is using for their cars, for their vehicles. Yeah. So since I was child, yeah, I have been passionate about computer engineering. So today I'm excited to share my insights on vehicle network protocols. So let's explore this, how to say, this fascinating world together, and I hope you guys will enjoy the presentation. So uh, let's dive into the content, the agenda. So in the first chapter, we will set the stage, introducing uh, the main themes and goals of our exploration. So in the second chapter, we'll see the importance of vehicle network protocols. And then in the third chapter, we'll discover the secrets behind the scenes, if I can say it that way, the main protocols used in the cars, in every vehicles. Yeah. So we will discover, their roles and how they make your car a well orchestrated symphony of functionality. So in fourth chapter, we will see the future trends of the vehicle protocols. And then next, we will navigate through the challenges faced by vehicle network protocols. And finally, we will have the conclusion chapter. Okay, so let's tackle the introduction now. Okay, cars today are much more than just vehicles, right? That get us from point A to point B. They're like rolling computers, as we can see. For those that are in China, every day we can see the modern vehicles like computers, like fully electrical and automated, right? They are filled with various electronic parts that work together so that they can ensure a smooth, safe, and enjoyable driving experience. So think of them as a network of interconnected, safe, and interconnected systems. I wanted to say, much like how our phones or computers communicate with each other. So vehicle networks are the communication systems inside the vehicles that allow different parts of the vehicle to talk to each other. So then we can say that vehicle networking is a specialized communication that connects the internal components of vehicles. So vehicles here can be cars, buses, or trucks. And these internal components include some electronic control units that we call ECUs in the automotive industry. They also include some sensors, actuators, etc. So as I was saying, just like how we use our phones or computers to share information, vehicles have their own way of sharing data between the various parts of the in-vehicle architecture. So let's see the next page. Okay. So years before, vehicles were simpler, right? They had, for example, engines, brakes, and basic electrical systems. But nowadays, they're much more than that. Yeah, as I was saying, so they have transformed into sophisticated, sophisticated machines that rely heavily on advanced electronic systems and complex architectural, sorry for the noise, complex architectural designs. Yeah. So in vehicles today, we have many sensors, control units, and smart gadgets, right? So we even have computers in them that control everything from how the engine runs to how the music plays on the stereo, if I can say it that way. So understanding the complexities of automotive electronic and architecture. Oh, sorry. Sorry. So I was saying that we have many gadgets in them, like sensors and control units. So to fully understand the electronics in those modern vehicles, it's essential to, to grasp the underlying architecture, right, that supports these systems. So at the heart of the vehicle's electronic architecture is the network of electronic control units that we call ECUs, as I say. They are essentially mini computers, and each of which control specific functions within the vehicle. So let me explain. For example, the as we can see it on the picture here. Okay, so for example, the ECU, the engine control unit, manage the engine's performance, right? While the transmission control unit controls the shifting of gears in an automatic transmission. So similarly, each ECU is responsible for a specific set of functions. Okay. So next, let's see some electronic control units in vehicle systems. So we can see, for example, we have the brake control unit, the BCU, that manage the brake control systems by driving the brake motors with inputs from wheel speed, brake force, etc. We also have the body control module, the BCM, that handles most of the electronics associated with the body, such as central locking, lightings, power windows, immobilizers, etc. We also have the electronic power steering system that we call EPS, or we can also call it power steering modules, PSMs, and they manage the electric motor in the vehicle steering and provide an optimal feel to the driver based on the ride mode. So we also have the navigation control unit, NCU, that aids the driver with the navigation information, typically integrated with onboard display and GPS unit. We also have the climate control unit, CCU. It's also called an environmental control unit. So it's also abbreviated as ECU, but we can make the difference. So this is in control of air conditioning and airflow in the automobile. So we have then the suspension control module or suspension control unit, SCM or SCU, that manage the suspension or shock absorber in the four wheels to deliver a smooth ride experience based on speed, steering angle, etc. And then we have the telematics control units, the TCU, that collects various vehicle telematics information from the automobile, such as position, speed, engine data, driving characteristics, and send to the cloud. Yeah, so next we have the impact of electrification on vehicle architecture and electronics. So the rise of electrification in the automotive industry has brought a paradigm shift in vehicle architecture and electronics. So this shift in powertrain architecture requires so this shift in powertrain architecture requires a new approach to vehicle electronics, along with the software and connectivity features. So how to explain that? Let's take an example to explain this. Okay. For example, in an electric vehicle, the traditional engine and transmission are replaced by an electric motor and a battery pack, right? We can see that in the modern vehicles. So the traditional engine and transmission are replaced by an electric motor instead of managing the combustion process and like controlling the motor control and regenerative braking systems. So regarding this new approach, we can see the creation of new ECUs in electric vehicles, for example, such as the battery management system, BMS, that monitors the state of charge of the battery pack, that manages the charging and discharging process and also ensures the battery's longevity and safety. We also have the motor control unit, the MCU, responsible for controlling the speed and torque of the electric motor, and the vehicle control unit, VCU, that acts as the central hub that manages input from BMS, MCU, and other ECUs and provides overall control. So in modern vehicle, the number of these components typically varies from vehicle to vehicle. But for example, modern electrical vehicles can have approximately 70 ECUs, yeah, in their vehicle. So they can also exchange around 2,500 electronic signals among their different components. So these are just a few examples of the many ECUs that can be present in modern vehicles architecture. So next, let's tackle now the importance of vehicle network protocols. So yeah. So what is a vehicle network protocol? And in-vehicle network protocol, so let me make it clear. We can say vehicle network protocol as well as in-vehicle network protocol. But when here we're talking about vehicle network protocol, we refer to in-vehicle network protocol because cars can also make, how to say, networks with everything around it. So that's it. Here, in our case, we specifically talking about in-vehicle network protocol. So an in-vehicle network protocol refers to a standardized set of rules and conventions governing communication between different electronic components and systems within a vehicle. Okay. Oh, so to make, how to say, to make sure that all these electronic parts we just gave a short description about earlier talk to each other properly, we have something called in-vehicle network protocols. So they are like translators that help these parts understand each other's language. We have some parts that handle the engine, right? Some manage the brakes and others control the entertainment system in the car, right? So during the talk, vehicle network protocols help all these parts talk together, helps all these parts understand each other. So that's the importance. So next, let's see how protocols make vehicles functions better. So every ECU in a vehicle architecture uses specific protocols. So these in-vehicle networking protocols transmit messages within a predetermined time limit and ensure that the messages are delivered correctly. So yes, now vehicle network protocols make things better. I will give a few examples. First of all, they enable efficient communication, right? So let's take an example here again. Just imagine your car as your car without any protocols, right? It would be like trying to have a conversation with someone who speaks a different language, right? So vehicle network protocols act like a common language that all these electronic parts understand. I think I just said that. So let's not think too far away. For example, this online meeting is a perfect example. So why? Some of us native language is, for example, English, right? And others speak French, others speak Spanish, and so on. But we all agree for speaking English to make everyone understand what's taught in this meeting, right? So then that's how vehicle network protocols enable efficient communication between these different parts, these different components, allowing them to exchange information in real time. So the second thing is that they enable coordination for enhanced functionality. What the meaning of enhancing functionality? So again, here, let's take an example. I'm thinking about which one. For example, we just talked about the engine, the brakes, and the entertainment, right? The entertainment system. Let's take an example about them again. So they all have their roles, like their roles in the car, in the vehicle, right? So protocols ensure all of them coordinate their actions seamlessly. So let me explain again. When the engines needs more power, for example, the protocols ensure it communicates with the fuel system and other parts of the vehicle so that the required performance can be delivered to it, right? So if you hit the brakes, for example, the protocols make sure the message gets to the right place to stop the car safely. So this is one example, and that's how is performed that coordination. So, and next, protocols also enable standardization and compatibility. So protocols, how to say, protocols also bring a level of order to the chaos. Why do I say that? They standardize the way different parts of the vehicle communicate, right? So imagine if every car manufacturer had its own way of developing its systems or its own way of developing the parts of the vehicle. So how these different parts would talk to each other. It would be a mess also, right? Then protocols provide a set of rules, right? Um, a set of rules that every car manufacturers, every embedded software developer, or every automakers can follow, right? So this standardization allows different companies to, how to say, to build compatible systems that are fostering innovation and ensuring that your car's various components can efficiently talk to each other and they can work together smoothly. So that's it. And then next, we will talk about the next chapter, that is the common vehicle network protocols. So we will list some of them. Actually, there are, how to say, there are many in-vehicle protocols, but we will just talk about the very common, yeah, of them, the most important ones, yeah. But actually, all of them are important, but we'll just talk about the common one, the main one, that almost 90% of any car manufacturer has in their in-vehicle architecture. So, so what are the different communication protocols, available at this time? So the different protocols available can broadly be categorized into three types, right? The first type is the data link protocols, right? Where the data link protocols take care of, how can I say it, of they take care of the physical layer implementation, right? We have the CAN protocol that stands for Controller Area Network. We have the LIN protocol that stands for Local Interconnect Network. Next, we have the FlexRay protocol and also the Ethernet protocol. So let's note that these are only the common data link protocols that are listed here, as I was saying. So they're actually much more than that. So next, we have the second category, that is the application protocols. They use the data link protocols as the underlying layer. So we have the UDS protocol that stands for Unified Diagnostic Services. We can see the J1939 protocol, the CAN Open protocol, and the MOST protocol that stands for Media Oriented System Transport. And then we have the other protocols with like Bluetooth, Wi-Fi, USB, and 4G or 5G mobile networks. So there's one thing we need to recall. That thing is that how to say, all these protocols are only a few among many in vehicle networking protocols, right? But today in our presentation, we will just talk about the data link protocols. We will not have enough time to talk about all of them together, and we will not go into really details of them. We will just talk about the general information about them. As I also heard that most of you guys are like students. Yeah, and yeah, that's it. So next page. First one, we're talking about the CAN protocol. So what is CAN bus? We can also call the CAN protocol the CAN bus. Why? Because it's also defining its topology. Most of you guys are IT students or professionals, right? So we all learn about the different topologies used in networking and so on. We have the bus topology, the how to say the merge topology, the daisy chain topology, the star topology. So that's it. That's when saying CAN bus, we are also defining the topology that this protocol is mainly using. So here, your car is like a human body. The controller area network, also called CAN bus. So the CAN stands for controller area network. So this is the nervous system enabling communication. So in turns, nodes or electronic control units, ECUs. So we will be talking about sometimes nodes or ECUs. So if we talk about nodes, then that means we also talking about ECUs, right? So they are like parts of the body interconnected via the CAN bus, right? So information sensed by one part can be shared with another. Okay, I think that's a quite simple definition of what CAN is, right? So CAN helps different parts of your car, like the engine, again, and brakes, send messages to each other. So it's super reliable. It makes sure that messages get delivered without getting lost or mixed up. Okay, so the next page. So specifically, an ECU can prepare and broadcast information like sensor data via the CAN bus. So the CAN bus consists, as we can see on the picture here, it consists of two wires. So we have the CAN low and the CAN high. So the broadcasted data is then accepted by all the other ECUs on the CAN network, right? And each ECU can then check the data and decide whether to receive or ignore it. So next page. We will talk about the CAN bus physical and data link layer based on the OWCC model. So in more technical terms, the controller area network is described by a data link layer and a physical layer. So in the case of high-speed CAN, ISO 11898 describes the data link layer, while ISO 11898 describes the physical layer. So there are also standards to describe the layers in case of low speed CAN. But here is just an example. As I said, we will not dive into too much details because these are really huge topics. So we will just talk about the general things. Yeah. So the role of CAN is often presented in the 7 layer of the OWCC model as per the illustration here, as we can see. So yeah, next page. So now let's give a brief outline of the 2 types of CAN bus we just saw, the high speed CAN and the low speed CAN. So the high speed CAN bus, what to say about it? The high speed CAN bus is by far the most popular CAN standard for the physical layer, supporting bit rates from 40 kilobit per second to 1 megabit per second. So this is a classical CAN. Actually, there's a more advanced version of CAN, but we will not talk about it too much. Yeah, this is just the basics so that you guys can know about the existence of these protocols and their importance. So, next, the low speed CAN burst. So these standards enables bit rates from 40 kilobits per second to 155 kilobits per second and allows the CAN bus communication to continue even if there's a fault on one of the 2 wires. Hence, it is also referred to as fault-tolerant CAN. So this was the 2 types of CAN bus. Now let's tackle the next part. So the top 4 benefits of the CAN bus. Today, CAN bus is standard in practically all automotive like cars, trucks, buses, tractors, bikes, and even ships, EV batteries, planes, machinery, and more. So they are like there are, how to say, there are 4 key benefits to CAN bus that help explain the popularity of this protocol. So first, the CAN bus is simple and low cost, right? So ECUs communicate via a single CAN system instead of via direct complex analog signal lines, reducing errors, weight, wiring, and cost. So second, it is second, it is, how to say, it is fully centralized. So it has easy access. So the CAN bus provides one point of entry to communicate with all network ECUs, enabling central diagnostics, data logging, and configuration. So third, CAN is extremely robust. Why? In particular, the system is robust towards electric disturbances and electromagnetic interference. And that's ideal for safety critical applications. So finally, it's really efficient. CAN frames are prioritized by ID so that top priority that data gets immediate burst access without causing interruption of other frames or CAN errors. So the next page, we have the history of CAN bus. So okay, I see the time and there is no too much time left. Okay, I will be fast. Okay, so what to say about the CAN bus history in short? So in terms of the history of CAN bus, in the 90s, there was a pre-CAN time where there was a pre-CAN time. So car ECUs relied on complex point-to-point wiring. Then the CAN bus was initially developed in 1986, where Bosch developed the CAN protocol as a solution to the prior challenge of complex point-to-point wiring in cars. So in 1991, Bosch published the CAN 2.0, with CAN 2.0A referring to 11-bit CAN IDs and 2.0B referring to 29-bit CAN IDs. And in 1993, CAN was adopted as international standards, ISO 11898. So in 2003, ISO 11898 becomes a standard series separated into the data link and the physical layers. So in 2012, Bosch released the next generation of CAN called the CAN FT 1.0. This is the CAN, the generation of CAN I was talking about earlier. This is the most advanced CAN protocol. So with FT, that stands for flexible data rate. So in 2015, the CAN FT protocol was standardized ISO 11881 and is gradually being rolled out in vehicles and machinery today. So in 2016, the physical CAN layer for data rates up to 5 megabits per second was standardized in ISO 11898-2. And more recently, work has also begun on the, on the next generation of CAN, called the CAN XL protocol. Okay, so now let's talk about the LEAN protocol. So what to say about the LEAN protocol? What is LEAN bus? LEAN bus is a supplement to CAN bus. So we just saw the CAN bus. It offers lower performances and reliability, but also drastically lower costs. So this is how the LEAN buses look like, as we can see on the picture. It looks like many clusters of LEAN bus in different parts of the vehicle. So next, let's make a quick comparison of the LEAN bus versus the CAN bus. So you can see that what we say, the LEAN bus is just a supplement to the CAN bus. So the LEAN bus is interconnected, is also connected to the CAN bus. So sorry. Okay. 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 So here is a quick overview of the LEAN bus and a comparison of LEAN bus versus the CAN bus, right? So by looking at the picture, we can understand that why we say that LEAN bus is a supplement to CAN bus, right? So a LEAN cluster consists of one master, and this master is the nodes connected to the CAN bus, right? The LEAN bus has one master and many slaves, right? So it can have up to 16 slave nodes, right? So the master node or ECU serves as the gateway of the LEAN cluster. I hope you guys are familiar with terms like gateway and its definition, right? Since I think we are all IT professional students, I think, as I was saying. So anyway, in simple terms, the LEAN gateway is the node or ECU from the Lean cluster, from which data from the Lean cluster will be passed to the CAN cluster. So Lean is generally lower cost. That means less harness, no license fee, cheap nose. A Lean master typically serves as gateway to the CAN bus. Lean is deterministic, not event-driven, and Lean clusters have a single master, while CAN can have multiple. So CAN offers up to 1 megabit per second, while Lean at max offers 20 kilobit per second. So I think for the history we will skip it since we don't have too much time left. We will go to the next page. We'll talk about the Lean bus applications. So today, Lean bus is a de facto standard in practically all modern vehicles, with examples of automotive use cases below. The steering wheel, for example. We have the steering wheel cluster that may include cruise control, wiper, climate control, and radio. We can also apply it at the comfort cluster that can include sensors for temperature, sunroof, light, and humidity. We can also have the powertrain, where we can apply some Lean clusters with sensor for position, speed, or pressure. An engine cluster may include small motors, for example, cooling fan motors. The air conditioner may involve motors and the control panel, which can often be complex, really complex. And in the car doors, a Lean cluster may involve side mirrors, windows, seat control, and locks. And in the seats, a cluster may involve position motors or pressure sensors, while other automotive use cases include window wipers, rain sensors, headlights, and airflow. So further, Lean bus is also being used in other industries. For example, in home appliances like washing machine, refrigerators, stoves, or in industrial automation like manufacturing equipment or metalworking. So next. Here we will provide an example. So we can consider the interaction between Lean and CAN bus in Windows control. So Lean nodes are typically bundled in clusters, each with a master that interfaces with the backbone CAN bus, right? So for instance, on this picture, we can see a network of 2 Lean clusters connected to the CAN bus in a car. So at the front left seat, we can just watch the picture. I mean the driver's seat, you can roll down the right seat window, right? So to do so, you press a button to send a message via one Lean cluster to another Lean cluster via the CAN bus, right? So this triggers the second Lean cluster to roll down the left seat window. So that's one example of Lean application among many others. So next. So how does Lean bus work? Lean communication at its core is relatively simple. So a master node loops through each of the slave nodes, sending a request for information, and each slave node responds with data when polled. So the data bytes contain Lean bus signals in raw form. So next one. Now we will talk about the FlexRay protocol. So Here, sorry. So how to say, what is the FlexWire protocol or the FlexWire bus? So FlexWire is a scalable, flexible, high-speed communication system that meets the challenges of growing safety relevant requirements in the automobile. So it was developed by a consortium of automotive manufacturers, including BMW, Daimler, AG. Daimler is actually Mercedes-Benz and General Motors. So the motivation behind developing the FlexWire protocol was the need for a communication protocol that could support the increasing complexity of the automotive systems. So nowadays technology advanced, right? Traditional bus systems like CAN were no longer sufficient to handle the demands of modern automotive applications. So this is how the FlexWire protocol has been developed. So as we can see on a picture, FlexWire uses a dual channel communication system, which provide redundancy and fault tolerance. So the two channels are synchronized to ensure that the data is transmitted at the same time on both channels. So this redundancy helps to improve the reliability of the system, so that any fault in one channel can be compensated by the other channel. So next. We will talk about the FlexWire topologies. So we have many topologies for the FlexWire. We first have the bus topology. So we are mainly talking about FlexWire bus, but actually it's the main topology used for FlexWire protocol in vehicle architecture, but it can also be used in concordance with other topologies. So the first topology is the bus topology. So it's commonly used. A single network cable connects multiple ECUs. We also call that bus topology a multi-drop bus, a multi-drop topology, so that one message can reach, ECU can have access to a message that is sent over this bus. So only one ECU can transmit at a time. So, and we have terminated end to eliminate signal reflection. And then we next have the star topology. And this star topology, individual links connect to a central active node. Also, they are used for more extended networks. If one node fails, it does not impact other nodes. The reduced amount of exposed wire helps increase noise immunity. So next we have the hybrid topology. So the hybrid topology is formed by combining the bus and star topologies of the FlexWire. So it offers the best of both topologies, and it's cost-effective, reliable, and easy to use. So next we will talk about the features of FlexWire. So the features of FlexWire protocol are as follows. First up, it is redundant, right, and fault tolerant, what makes it highly reliable. And then it has a high data rates up to 10 megabits per second. It's versatile, it's fault tolerant, we say that. It's event and time triggered. It's also dual channel system. Also error tolerant, it guaranteed message latencies, it has fixed communication latencies, and yeah, we also, okay, it's event and time trigger, as I said. So next, we have the comparison of the FlexWire protocol versus the CAN protocol or the CAN bus. Here, we can see that FlexRay is dual wire options between single and dual channels, while the CAN is dual wire and single channel only. So next, the FlexRay is multi-master. That means it has up to 64 nodes. The CAN, while the CAN is multi-master from 10 to 30 nodes. We have the FlexRay that is time and event triggered, while the CAN is only event triggered. We have the FlexRay that is that has constant latency, while the CAN load the CAN load is load dependent, sorry. And then the FlexRay offers up to 10 megabits per second, while the CAN at max 1 megabit per second. So next we will, I think we will skip the FlexRay history. Because we don't have too much time. And then we'll talk about the FlexRay applications. So we can have on we can have the FlexRay on electronic power steering, FlexRay cluster. We can have the FlexRay cluster on advanced driver assistance systems, for powertrain, for body control module, for battery management system, anti-lock braking system that we call ABS, also for vehicle stability control, VSC, and for vehicle stability assist, VSA. So next, we will have like a FlexRay example for the FlexRay use case example. Yeah. So for example, we have the autonomous emergency braking AEB system that we will use for our example. So this system it enhances vehicle safety by automatically applying the brakes to prevent or mitigate a collision. And the different components involved are the sensor suite that are, for example, the radar and camera sensors. We also have the ECU managing that function. And this ECU is the central brain of the AEB system. We also have the brake control module that we use to apply the brakes. And we finally also have the FlexRay communication network, the FlexRay protocol, that is real-time and deterministic communication between the sensor suite, ECU, and the brake control module. So how the whole operation works. The first thing done is the sensor data acquisition. So all the signals and images captured by the radars and the cameras are sent to the ECU via the FlexRay communication protocol. So second, the ECU then processes this data to assess the risk of collision by considering factors such as the distance to that potential impact, the speed of the vehicle, and the trajectory. So then based on its own analysis, the ECU decides whether an intervention is necessary to prevent that collision. So in the case a critical situation is detected, it immediately triggers the AEB system. Therefore, thanks to the real-time communication feature of the FlexRay protocol, we can ensure that this critical information is transmitted without delays, and that allows the brake control module to rapidly engage the brakes. So this module will then engage the brakes with the corresponding, the appropriate force that can be used to either avoid a collision or minimize its impact. So that's a use case of the FlexRay protocol among many others. So next page. Now we'll talk about the Ethernet protocol. Okay. So What is, yes,
hello.
yes,
You still
hello.
have more slides left
Yes, yeah, I didn't start early, sorry.
because
Yeah, I
the
still have
time is.
a few slides left, but I will be fast, I think.
Oh, okay, okay,
This is the last point actually, the last point of the different communication protocols that we
okay,
need to talk about. Yeah. So the Ethernet bus is what it is. It's a high-speed bus, right? It's a high-speed data transmission bus that can be used to support high bandwidth um, uh, bandwidth automotive applications such as advanced entertainment systems, remote diagnostics, and in-vehicle communications. So the Ethernet bus supports many different transmission rates and communication protocols, such as we all know, I think, about the TCP/IP protocol and the UDP protocol. So next slide. The Ethernet has many topologies that are the ring topology, the interconnected topology, the star topology, the tree topology, the mesh topology, and the daisy chain topology. All these topologies are allowed, if I can say that way. We can implement them in the Ethernet protocol. So next. Now let's make things clear about the different types of Ethernet that exist, and then we'll make a quick comparison of what we are seeing on this page. So there are two types of Ethernet actually. So first we have the standard Ethernet. I think even if you're not an IT student or professional, you have at least once heard this name in your life. So it's actually a transfer medium that can handle a large amount of data like internet infrastructure, how to say, also it can handle high-speed data centers or again, offices or homes. We surely have Ethernet in your home, but this is a long time ago. So the second type is the automotive Ethernet. So by hearing this, I think you can be scared if it's the first time you hear it. I don't know about you guys, but it was my case. When I heard it for the first time, I was like scared. I was like scared. I was straight out of my IT classes and I got into the automotive industry without knowing anything about it. And suddenly I got into the first professional project of my life, and I never heard about it before, but I've been given how to say a huge project on developing a software to test an automotive Ethernet-based communication protocol. So I was like, oh my God, I'm gonna lose my jobs. So I was really scared, but hopefully I didn't lose my job, and we closed the project successfully. So to make it simple, automotive Ethernet is just the standard Ethernet, but used in automotive industry. That's it. So that's simple. That's it. So the automotive Ethernet has a data rate of 10 megabit per second to 10 gigabit per second, while the standard Ethernet has a data rate of 100 megabit per second to 400 gigabit per second. So you can wonder why there is such a, how to say, such a huge difference, despite the fact that it's the same technology, but just in a different environment. So if you did so, then you got your answer, right? Your answer is inside that question. Because of that difference, I think the difference between the different points, the data rate that we can see here between the standard Ethernet and the automotive Ethernet is just the environment, because standard Ethernet is used for infrastructures, right? But automotive Ethernet is used in vehicles, in cars. So in cars, we know the conditions of the different components. So it's really harsh inside vehicles. So they can be like interferences and so on. So that's why we can use we cannot use the full potential of standard Ethernet in automotive Ethernet. I mean in vehicles. So next, so yeah. So finally, I think we can see the features of the automotive Ethernet here. It's we can have the high definition video streaming. Uh, Thanks to the automotive Ethernet, we can have the over the air updates and also the sensor data fusion in autonomous vehicles. So next, we will skip the
Honorable
yep.
Speaker, if you can share the PPT with me, that would be great,
Yeah,
because we
okay.
have 15 minutes, and also there are some questions here for you from the audience.
Okay, okay,
So
no
let's just
problem.
give
Okay,
maybe 5 minutes to the question and answer session. And then those that need to read more, they can read through the PPT
okay,
later on.
o-
But there's a
okay, yeah,
question here.
okay, no problem. I also wanted to do a use case example. I mean a practical example. So I don't know.
Oh, okay.
Yeah,
And
yeah,
there's,
yeah. I think I didn't start early, right?
yeah, let's
Yeah.
see this. Let's take the question and
Okay,
answer. If the
okay,
time
okay,
is still there,
okay,
we will take on the practical part. But there is
okay,
one
okay, no,
question here
okay.
from Abdullah. I said that's Abraham. Abraham say, what is the simulation software you can recommend for vehicle network protocol design and optimization for practice?
For practice, actually, uh, 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 personally, I'm not using any simulation software for practice. Actually, we are simulating ECUs of network protocols through some open source implementation, you know. So
Okay.
we are generally testing the ECUs actually. So we are working on the ECUs right now. So I think for the networking part, I think you can answer that question, right? Because I think you are networking like
Yeah, so
professional, I think.
okay.
Yeah,
But I think for the networking aspect, those
yeah,
guys that are interested, they can use the Cisco Packet Tracer.
yeah.
That is the best visual environment for simulation and stuff. But then there's another question here from
Mhm.
Henry. It is possible to reset the memory of the vehicle to allow it function properly as we usually do with our mobile phone.
Reset the memory of the vehicle.
Yeah.
You know, it's not that easy because as I was saying, I was talking about ECUs, right? Uh, it's like many computers in that vehicle. We cannot only reset that memory, the memory of all these ECUs in one time. It will be, it depends on the aspect you want to handle, right? If the parts you want to handle, if you want to reset the memory, I mean, to reset the function, I don't know, you just go to the specific ECU, right? Take the ECU as the operating system, the computer handling the parts you want to fix a bug. I don't know what it is, but it's like many computers in a vehicle. It's not only a matter of resetting all of the information in the vehicle. Yeah. Did I answer
Oh,
your
okay.
question? I don't know. Yeah.
Yeah, I think I also understand that because the different devices have different
Yeah,
models and different operating systems, so you have to deal
yeah,
with it
yeah, that's it.
separately instead of a
That's it.
general memory for the entire vehicle. There is no
Yeah,
general
yeah,
memory for
yeah,
the entire
yeah,
vehicle.
yeah. There is no
So I
general
think
memory for it.
okay, so the PPT will be shared because of time. We have to talk about maybe other things for tomorrow. So the PPT will be shared, and if we have much time tomorrow, I will appeal to him to come back and give us some demonstration because of time. Because if we keep you here more than the time, you'll be like, nah. So I will talk to him and see if we can get him tomorrow. But Henry, I think Henry hand is up. You still have one question. So let's get Henry, and then after we will call it a day for our speaker. So Henry, you can unmute yourself. I just sent you an invite. Henry.
Okay, thank you. I'm calling from Liberia. I'm Henry.
Yes,
So,
hello, Henry.
the question I just asked you
Mhm.
about resetting the car memory, all came about. I did a research, and then this teacher advised me our vehicle has a computer system, which is the computer box. When usually you're about to start the car, you insert the key or where your car is thumb start, you touch the brake and you put your thumb right there, the car will start. So there's a message that goes straight to the computer box. So once the car is not starting, your dashboard, you have a light on the dashboard, brake fluid, all these things are low. So how can you get rid of all these error messages? So, and then he replied, he said, there's a common steps you need to do. Just open your hoods and go to your engine, connect the negative pole of your car to the positive pole for 15 or 10 minutes and just close all the doors, lock everything, and the car memory will automatically be reset and everything will function properly. So, and I did that test and I got a solution. It was positive. Yeah, so that's it.
Okay, so okay, thank you. I got it.
Okay.
Okay.
All right. So ladies and gentlemen, just send in your appreciation messages in the chat box to our speaker. Thank you so much, Cedric, for the presentation.
Yeah.
At least today we get to understand a little bit about our cars and our future cars because not everyone have a car yet. But I think we all understand a little bit about how this whole vehicle network or vehicle as a whole, the communication aspect of it, how things operate there.
Mm.
So tomorrow or another time, if you have a car, at least you understand that things are not just operating by magic, but there are some protocols and standards that drives the way we see the car. So for some of you that joined late, we already have the certificate thing. We already have it. So the certificates, they are here for 98% of the certificates have been prepared. So some of you, the reason why a certificate was not prepared is because you did not register officially. So we couldn't find your registration ID. So that means we have to generate a unique ID for you since you did not officially register, though you attended maybe 3 days or 4 days and all of that. And for some of you, we created a certificate already, assuming that you will complete today and tomorrow, then we can give you a certificate. But in case you don't attend tomorrow, and we also check from day 1 to day 4, you also miss maybe 1 or 2 days, then we're going to delete your certificate by pressing Control, Alternate, and Delete. So there will be no way to get it from the recycle bin except we use another recovery software. For the speakers, for the volunteers, the certificate also, they are all set and ready. And we will start to distribute a certificate via your email, your WhatsApp, your Instagram, or whatever place you want us to send your certificate, but by default, it's the email. Whatever place you want us to send a certificate, we're going to ensure by sending it to those places at the end of tomorrow's section. For those of you that will be doing your discussion tomorrow, it's 15 minutes. And just in this pattern, you already know which position you are on, either you are defending or against, you already know that. So you have to prepare properly. If you want, each person on the team will get like 1 minute for that time to speak. So the first person have to lay the basics of the topic and just a summary of convincing us why you think students should use ChatGPT or generative AI tools for their research, okay? The second person from team B will also come and tell us why you should not use it for your research or academic work. Then the second person from team A will now come and say to rebut why the people from team B, why their point is wrong. Also, the second person from team B will come and tell us why the people from team A, their point is also wrong. Like that, the third person from team A will come and do a crossfire. The last person will do the summary of their discussion from each team. So that's how it's going to be like. But we'll see you guys tomorrow. Let me just make sure I get this attendance thing ready. But your certificates, they are already here. So please ensure to complete tomorrow. You already know your attendance record. We already share in the group. So if you think your attendance is dangling like a dangling modifier, then you have to at least attend today and tomorrow to reconcile that information. So it's time now for our attendance. Let me just get it back up here. And right after, we will open up if you have anything else to say. So tomorrow we also have, I think Daniel should be coming back to talk about or give us the conclusion on the ODU system. We just gave him maybe a few minutes to do that. And right after, if time is permitted, Cedric, our speaker for today, will come and also give us a summary as well through the demonstration on his part. And we will also have Bosco tomorrow, who will also be here to tell us about his music and his project that will be launched hopefully by next month. So I'm doing the backup for now for the attendance. And right after, we were going to open up this thing here because we don't want somebody saying I was here and you did not recall me in the attendance. So as much as you are here, we're going to get a record for you. Some of you use different name when registering. Some of you also use different name here on Zoom, but we were able to reconcile that because we checked both the registration system and also the Zoom information to cross-check and make sure that the information that we are putting on your certificate is accurate. But in case we give you a certificate and you still have problem, maybe you want your name to be changed or you want something else to be included, we will be available to help you make those changes. So we have already taken the backup. Let me now stop sharing, and also you can turn on your camera. Let me give you that permission to do so. You can turn on your camera and let's take our attendance. Right after, I will open up the microphone. For some of you want to speak now, we cannot hear you. Okay, so let me just turn on your camera. Let me just do this attendance quickly. All right. So thank you for joining today. Tomorrow is the last day. You don't want to attend all of these days at the end of the day and not get a certificate. So since you are here, ensure that you complete. And also, we'll start to get a certificate out beginning tomorrow. So within 2 days or 3 days, if you don't hear from us or don't receive a certificate, just know that probably you weren't qualified, or maybe it's a mistake on our part, you can reach out to us. But the certificate will be ready beginning tomorrow. We start to send out a certificate. So you can imagine if you don't receive it in 3 days, then I don't know what really is the problem. So you just let us know by sending us a message that I have not received my certificate, but I've attended all of the days, or I've completed all of my attendance, and these are my proof. You can also check it. Then that way we can make the necessary correction and send your certificate to you. Besides that, if you don't have any proof, you go explain tire. No evidence. Okay, so let me take the last screen, and then we're going to open up the microphone if those want to. I've already shared the link, the various AI tools and website for day 5. I already shared that in the chat box. So if you just joined because of the attendance, then that means you miss it. I think I shared it twice today. So if you just joined because of the attendance, then you miss on all of that. And also we have some of the participants will be speaking to us tomorrow, letting us know if it's prudent enough for us to do or to use this AI system for our research or not. So many of us here are students. So the students will be telling us, yes, I think it's okay that we use it, and based on this fact, according to Harvard University 2024 article, they say it's we can use it or not. Let me unmute. Okay, you can be able to unmute yourself. Thank you so much for joining today. Tomorrow is the last day. The winners, if you are in Africa, I think you use mobile money there. We'll send your prize through mobile money. If you're in China, we'll send your prize through Hongbao. That means you have to. That means you have to add our WeChat, or we just send it directly in the group if you're in the TIT group. The person that will send the mobile money, the person is already here on this platform, so he's already ready to make the transfer. Besides that, we are already set and ready. I'm going to stop recording.